let's try another example where in this case now we're looking at the integral from -infinity to 0. So we'll start by rewriting this as the limit as t approaches -infinity of the integral from t to 0 Now, in this case, to evaluate the limit, notice that we're going to want to use integration by parts. So we're going to do integration by parts. So let's choose u equal to x and dv equal to e to the x. So I get du equals dx and v equals e to the x. So now using parts to evaluate the limit, to evaluate the integral, we'll save the limit for the end. We'll have, let's see, u times v is x e to the x minus the integral of v times du, so e to the x dx. Notice that here we're evaluating each of these from 0 to t, from t to 0. So that'll be the next step, would be to evaluate. So here evaluating this first one at 0, we'll have 0 times e to the 0 is just 0, minus t e to the t. Then of course here this will just be e to the t, or e to the x evaluated from t to 0. And this should be -infinity. Okay, so we have negative t e to the t minus, and then this will be e to the 0 minus e to the t, so e to the 0 is 1. And now let's see how we can evaluate this integral. Now notice that this integral, evaluate this limit. So notice that this limit is an indeterminate form because as t approaches -infinity, we got this negative t here that goes to infinity, and then e to the t actually goes to 0. So I'm going to use L'Hopital's rule, but before we use L'Hopital's rule, I need to write this as negative t over e to the negative t. So I'm just going to bring this guy to the bottom. So now it's in the indeterminate form. Here, let's make sure it's negative. But as t goes to -infinity, this piece here will go to 0. Right? And now we see that what we're left with here is in the infinity over infinity form. Okay. Oh, and I should not forget there's also -1 here. So yeah, whatever we get here for this limit, we'll subtract 1. Okay, but here let's do L'Hopital's rule. And so taking the derivative of the expressions in the numerator and denominator. So the derivative of negative t will be -1, and then downstairs we'll get negative e to the negative t. And now taking t to -infinity here, well, this would just be actually here I can bring e to the negative t back to the numerator as e to the t. And then taking t to -infinity, we see this, it goes to 0. Okay. So in the end here, we get a limit of -1. Okay, so basically what that's telling us here is that the area of this sort of like left half region of the graph is -1. So perhaps it makes sense that it's negative, because if we were to look at the graph of this, I think we would notice that yeah, it would be below the x-axis there. As it goes to the right, it'll keep going up, but the area of now this region that we found here to the left is an area of -1 that's below the x-axis there. Let's try an example now where we've got the integral that goes from -infinity to +infinity. And the way we'll start it out is we'll start by splitting it into two. So we'll have one integral that goes from -infinity to 0. And here I'm choosing 0 sort of arbitrarily, but 0 seems to be an easy choice. But if you remember, any value that you choose to split it at is okay. Seems to make it easier to use 0 in this case. And then it's from 0 to infinity. Okay. And now we can evaluate each of these individually. Notice that 1 over 1 plus x squared, we know the integral of 1 over 1 plus x squared is tangent inverse. So let me first rewrite these each as limits. So this would be, the first one would be the limit as t approaches -infinity. Integral from t to 0. And this one would be the limit as t goes to +infinity. And then the integral from 0 to t. So this is 1 over 1 plus x squared. We know that integral is tangent inverse. Here evaluated from t to 0. Here the same integral, so tan inverse, in this case evaluated from 0 to t. So this first one will be limit as t approaches -infinity of tangent inverse of 0, which is actually 0. And then this one would be limit as t approaches +infinity of tangent inverse of t minus tan inverse of 0, which is 0. Okay. Now let's remember, here I'll just draw a graph to help us remember that for tan inverse, it's got these horizontal asymptotes at pi over 2 and -pi over 2. And as as the graph goes to the right, it'll approach +pi over 2. And as it goes to the left, it'll approach -pi over 2. So here for the limit as t approaches -infinity, this guy will approach -pi over 2. And as t approaches +infinity, as it goes to the right, tan t will approach pi over 2. So here our answer will be, okay, so 0 minus -pi over 2, so pi over 2, plus, this will be pi over 2. So we got pi over 2 plus pi over 2 equals pi. Okay, so what we've shown is that the area under this curve, which if we were to think about the area under this curve, 1 over 1 plus x squared is actually sort of a bell-shaped curve. Looks more like this. And the area under this is equal to pi. going from one, so all the way from the left end, which would go all the way out to negative infinity, all the way to the right end, going to the right forever.